Hello everybody, and welcome to yet another lesson for college algebra. In this lesson we will talk about polynomial inequalities. And within this lesson we will talk about what it looks like when a function is positive or negative, and then a lot of more of the same from the previous couple lessons of finding your zeros and the multiplicities and the behavior of each zero, and then the end behavior, and then plotting a graph. And then we just have to start answering questions, or just finish up with answering questions. Are we looking for where the graph is positive or negative? Let's jump in. Okay, so positive, negative, what? How can you tell if a function is positive or negative? Well, first I want to go over what it means for a function to be positive or negative. Then you should be able to tell. So here's what happens. You all should know that way back at the beginning of learning about functions, we introduced a second variable and we called it y. Then we quickly took that variable y and we replace it with function notation. So if we're trying to figure out where a function is positive or negative, we will be trying to figure out whether f of x is positive or negative, which means we're trying to figure out if y is positive or negative. Not just for one single spot, but for all of the function. Where are the y values either positive or negative? Well, again, in order to figure that out, I have to do a little more defining here. Here we have the x-axis, and you know that if you are anywhere on the x-axis and then move up, you have a positive y value. So anything that is above the x-axis we'll say is positive. Similarly, if you travel anywhere along the x-axis and then move down, the y value will be negative. So anything down here we would say is negative. Now what about being on the y-axis? If you travel along the y-axis and you don't move up or down, well, that's just a zero. That is exactly what we have been doing. We've been finding so many zeros, the y would be equal to 0. So if I draw any random graph here, I'm just going to do this. Ooh-wee. There we go. It is important to know where those zeros are. So there's one here. There's one here. Let me make this a little more efficient. There's one here and here. Pretty easy. There we go. Now, if we're trying to figure out where f of x is positive, I'm sorry, let me call this f of x. This graph is f of x. If we were trying to figure out where the function was positive, well, that means we're just looking at this graph at anything that's above the x-axis. So it's positive here and here. Pretty easy. If the x-axis, let's see, if the function was negative, that'd be anything below the x-axis. So here, here, and here. And forever this way, to the left and to the right. So that's it. Like, that's all we're doing. We have to, do a little bit of work to get to this graphing point. Right? We have to do a little work to get to this graph, like find the zeros and the multiplicities and the zeros of the behavior of the zeros and the end behavior and all that stuff that you've been working on. And we just make a sketch of a graph like this, and then we'll give some intervals. So what do I mean by that? Let me, there we go. Let's say this number right here is, this 0 right here is -7. This one, we can call it 0. This one, 3. This one, 8. So where is this graph above the x-axis? Well, if we're just talking about being above the x-axis, that means f of x has to be greater than 0. The y values have to be greater than 0 to be above the x-axis. Okay, so that being said, we have to remember that this symbol means we will be using parentheses. All right, so that just means between -7 and 0, it's above the x-axis, and between 3 and 8, it is above the x-axis. Pretty straightforward, not too hard. What if we change it? What if we say below and equal to 0? Well, that means we would have f of x being less than or equal to 0, which means now we are using square brackets. And in this case, that's all of this, so we would have to start at -infinity and stop at -7, and between 0 and 3, but we would include those values because of the equal to here. So 0, 3, and then lastly, we would have from 8 off to +infinity. And this is just a reminder that square brackets can go on numbers, but never on an infinity. You will always use parentheses with infinity. So let's take a look at, let's say, 2 examples of graphs where you're already given the graph and you have to interpret what is being asked of you to get an answer for whether a function is either positive or negative or equal to. All right. These 2 examples here, you're just given some graphs and you're asked to find, for this first one, where is the function greater than or equal to 0? You can think of this still, where is y greater than or equal to 0? Where are the y values positive or equal to 0? Okay, so the first thing we can do is very easily identify where is this function equal to 0? Where are the y values equal to 0? That's just asking, what are the zeros of this function? And just from a graph, they're right here, and right here. Pretty simple. So we have 3. We have -5, 0, and 6. Very good. Now, what we are trying to do then is come up with intervals. Our answer will have intervals. So again, these intervals have to either have parentheses or square brackets around the numbers. So since we will be having, since we have an equal to here, we will be using square brackets around the numbers. Now, how do we make these intervals? It's pretty simple. All we have to do is remember that this means above the x-axis. So I'm just going to come along and shade anything that's above the x-axis, like this interval here and this interval here. And to make it even easier, I'm going to put a square bracket on 5, 0, and 6. And this makes getting the answer so simple. This graph goes left forever. So our interval will start at -infinity and stop at -5. But the infinities, remember, always have a parenthesis around it. We have another interval that's right here. that is also included in our answer. So we will union 0 to 6. And that's it. That's all we're looking for. The second step here, or the second example over here in purple, you can see pretty easily that there is only one 0. Even though there's no equal to here, we still have to identify where that 0 is, because that is where the y values change from being positive to negative, or over here in the blue example, from negative to positive. The zeros play a very important role no matter if there's an equal to or not. It's just if there is no equal to, we use parentheses instead of square brackets like we did in the last example. So a less than, and f of x is less than, which would mean y is less than 0. It's basically asking you, where's this graph below the x-axis? There it is, and forever to the right. So we can see that 0 then is at -3. So our answer here would be -3 to infinity. And yes, it is that simple. It's that simple to get your answer. Let me write some steps down as to what you will need to do in order to get to this particular point here. So to solve, these are not linear inequalities. To solve polynomial inequalities, you have to quickly check if the function is quadratic, you will need to factor it and find the zeros. Otherwise, the function will be factored already. So that is to your benefit. The second step is you will want to make a ZMB chart and find end behavior. The third thing that you will want to do then is draw a graph on an x-axis. So for all of these, you do not need a y-axis. You only need an x-axis. And the graph will either be above or below. That's how you can tell if it's positive or negative. Then the last part of it will be the intervals, aka your answer. And there could be one interval or multiple intervals for your answer. So the intervals depend on zeros and the inequality sign. Basically your graph and the inequality sign. That's how you will find your intervals. Why do the intervals depend on zeros? Well, the zeros, only zeros, or positive or negative infinity, will be in the intervals. And why do the intervals depend on the inequality sign? Well, that tells you whether to look above or below, and tells you whether you should use parentheses or square brackets. Let's look at some examples. So for this example, this is a quadratic expression here. So if you have something that's quadratic, you have to factor it. And of course, I'm going to hit my factor button and get x plus 4 times x minus 2. So it's still less than 0. This sign will not change directions here. So from here, we create the ZMB. And with the ZMB, we know that the zeros will be -4 and +2, each with a multiplicity of 1 and having a crossing behavior. The end behavior will be positive because this sign is positive, so the right side will go up. And since we have a degree of 2, the left side will do exactly the same as the right. So the left side will also go up. So we have the ZMB and N behavior. The next step is that I want to draw this on an x-axis. So here's my x-axis. I'm going to have my -4 and I'm going to have my 2. I know these are crossing behaviors. I have my zeros right there. The N behavior looks something like this. And finally, since they cross, the rest of the graph will cross below the x-axis. Now, what we're trying to do is find out where is the graph of this function lower than below the x-axis. So I'm going to pick a different color here. Say it's right here. That is where it's below the x-axis, and because this symbol up here is just a less than and not equal to, I will be using parentheses. So the final answer here would be -4 to 2 in parentheses. All right, here we have another example. It's a polynomial. We have -5x squared times x minus 4 the quantity squared times 3x plus 5 the quantity cubed greater than or equal to 0. In fact, I think I'm going to change this just to be greater than 0. So this is not quadratic, so this is already in factored form for us. So what we get to do is jump right into ZMB. So zeros, multiplicities, behavior. So anywhere I have an x is a factor, an x factor we'll say. So I could set this equal to 0 and get a 0, 0. I could set this equal to 0 and get 4 for my 0. And I could set this equal to 0. See, 3x plus 5 equals 0. Subtract 5 from both sides, and then divide by 3 to get -5/3 as my last 0. Now for the multiplicities. The multiplicity just ends up being the exponent again. So my 0, 0 will have a multiplicity of 2. My 4 will have a multiplicity of 2, and the -5/3 will have a multiplicity of 3. So this means we will have a bounce because the multiplicity is even for both 0 and 4, and a cross behavior for -5/3. The N behavior for this particular function, since the leading coefficient is in fact a negative number, the right side will go down. If we add up all of the multiplicities, we can find the degree. Since the degree is odd, the left side of the N behavior will do the opposite of the right side. Since the right side is going down and the left side will do the opposite, the left side will go up. Next, we want to plot this out on the number line. So I just have to make sure the zeros are in the correct order. Your graph does not have to be to scale. Mine definitely is not. And I'm going to plot my zeros. Oops, I forgot to label these. This would be a cross, this would be a bounce, and this would be a bounce. There we go. So now for the graph, you've got to get the zeros down in the behaviors. So I've done that here. Then I have to get the N behavior on here, like this and like this. And finally, we have to connect. So this will be bouncing here, and it crossed over here at -5/3. So for this particular inequality, we are looking for intervals where the graph is above the x-axis. But we do not include the zero, so this will be a parenthesis. And we will say this is our only interval that is above the x-axis. So our answer here for where is this polynomial greater than 0 would be -∞ to -5/3. So what now would happen if I said, I don't like this greater than, let's say there was a less than here. Well, now we would be looking for wherever the graph is below the x-axis. And we would still be using parentheses. And we cannot include any number on the actual x-axis, which means we cannot include any of these zeros that we originally had. So that means we can be anything from -5/3 to 0, and from 0 to 4, and from 4 to infinity. So if we started with a less than, we would get this answer. If we started with a greater than, we would get this answer. I'm going to round out this video with a couple more examples. For this example, again, this is not quadratic, so it is already factored for us. So all we have to do then is find the ZMB. We have to find the end behavior, and we have to draw the graph. So here's the graph with the end behavior put in, and this will bounce, cross, and cross. Okay, so very quick explanation of everything that just happened. The zeros are found by setting each factor equal to 0. Subtract 4 from both sides, -4 is the 0. Subtract 1 from both sides, -1 is the 0. Add 9 to both sides, 9 is the 0. We can look for the multiplicities. The exponent for this 0 is 2. The exponent for this 0 was 1, so the multiplicity is 1. The exponent where this 0 came from is 1, so the multiplicity is 1. Since the leading coefficient is negative, the right side of the end behavior will be going down. Since the degree here is 4, which is even, that's really what we care about it. The left side will be doing exactly the same as the right side. So the left side is also going down. And I've gone through the graph already. So how do we get the answer here? The answer is, or the intervals we are looking for are where this function, or where the y's for this function, are greater than or equal to 0. Well, what that means is we're looking for all values that are either above the x-axis, like right here, or on the x-axis. So we have 1, 2, and then we have this oddball number over here. So for an interval, we will be using square brackets. So this from -1 to 9 is pretty easy to understand. But how would we represent a single number? We still have to have a union, but if you're only going to be representing a 0 with no interval associated with it to the left or to the right, you use curly braces like this. So if you just have a single value, and it will be a 0, remember I said zeros are the only numbers that will show up in our intervals. We can have the zeros or some type of infinity. In this case, we need this 0 as part of our answer because that makes the inequality equal to 0. So we have to include it. If there's only a single number, curly braces. Now, just like I did with the last example, I want to change this inequality sign. Let's say I make it less than or equal to 0. So in red ink down here, that would be everything here. We would include the 4. It would be everything here. We would include the 1. And that's it. At that point, it stops being below the x-axis. We exclude everything from the yellow portion here because that is above the x-axis. Again, I'm looking at less than this time. Then over here at 9, we'll pick back up and go on forever. So we can write our intervals out for this, and we don't stop in intervals. So we're going to start at negative infinity, and we do not stop the interval until we go above the x-axis. So as I travel along, this is on the x-axis. That's fine. We can be equal to. So I'm traveling along, I'm on the x-axis, and I'm back below. So still red, still red, still red. I'm on the x-axis, but now when I move past this 0, it's above. So we have to put a stop here, but not here because the graph did not go above the x-axis after negative 4, only after negative 1. And this interval I think is pretty easy to understand. So our answer here would be negative infinity all the way over to negative 1, union, it's a square bracket, there we go, 9 to infinity. Let's take a look at one more. Just kidding, this will be the last example. So I hope this makes sense, and I hope you will ask questions if you have questions. Also, just so that everybody out there knows, most of the time, these polynomials will not be factored, like the quadratic example I did. But I can test you on different topics on whether or not you can factor polynomials that don't look factorable. So I've decided to only work with polynomials that were already factored, just to test whether or not you understand how the inequality aspect of this works. So I hope everything is understandable. I hope you will ask questions when you have them. Good luck.